So Mod 4.5 is exploring more of those units of growth and decay. So let's take a look at problem number 1. Now, problem number 1 says that we have this function f of x equals 9.5 times the quantity of 1.24 to the x. Now, I'm going to start at the bottom. Remember, if we have this equation, this is always our initial value. If you don't see it, our initial value is 1. So we can easily answer for problem number 1 that our initial value is that front coefficient in front of our exponential portion. So it's just 9.5. Now, they didn't give us any context, but if it was money, that would be $9.50. You know, depending on if it was bacteria, it might be 9.5 milligrams of bacteria or whatever it might be. Okay. Now, the unit growth factor for this one. So if we wanted a 1 unit growth factor, it is just that 1.24. Okay. So let's go to what they want then for A. It's a half of a unit growth factor. So that would be 1.24 to the half power. Now you can also write that a half power, remember, is the same thing as a square root. So that just means if we went a half of an x unit, that's how much it would change. Now the 2 unit growth factor then, if you follow the same pattern, is 1.24 to the second power. But we really need to calculate that number if we were going to answer part C. Okay, so let's answer. Let's do that multiplication out so we can answer part C. So if you had a calculator and you plug in 1.24 squared, that is 1.5376. Now, part C is dependent upon part B. It says, what is your 2 unit percent change? So if we see our percentage or our decimal value in part 2, that's the same as 153.76%. So remember, percent change is a comparison with 100. So how did it change from 100? So whatever it is, you're going to subtract 100. So 153.76 minus 100 is 53.76% change. It went up by 53.76% compared to if it started at 100. It now is 153, so it went up by 53. Okay. Now, following this same procedure, let's move on to or question number 2. Remember that initial value is 0.46. That's that front value. Our 1 unit decay factor is what they're asking for in part B, but we have something funky going on here. Okay, so let me show you what happens when you have something on there. So our a fourth of a unit is actually 0.874. Now let me show you why. Because of that 4, you kind of can think about if I had 0, this is the best way I think to do it, 0.874 to the 4x equals 0.874 to the first, and solve it for x. So you get that 4x equals 1, or x equals 1/4. So that's why it's a 1/4 unit. So if you're multiplying by your x exponent, you have to divide that off. If you're dividing, you have to multiply that, if that helps, okay? So our 1 unit growth factor, if this is our growth factor to a 4th, then what we need to do is we need to take and multiply that out 4 times to see what 1 whole is. So 0.874 to the 4th is going to actually be 1 unit. So it's going to be 0.5835. But I would probably just write it as 0.874 to the 4th. Okay. So again, it's a strange process when your power is multiplied by something. The thing inside is going to be 1/4. Because see how would you make that a 1? Well, you would make that a 1 by making your x 1/4, if that helps. Now, so a 5 unit growth factor, if you have the 1 unit growth factor, now from now on we can find it pretty easily. Now they want the percent change, so we're going to find the growth factor and then we'll relate it back to a percent. Okay, so if we take that 0.5835, which is now our 1 unit growth factor, and take it to the 5th power, so I had that in my calculator already, I get 0.0676439. Okay, now they want the percent change. That's the growth factor. They want the percent change. So remember, we always subtract 100%. So that's going to be 6.76439%. So you take where it landed, 6.76439% minus 100%, and we get a negative, because it went down. It is not 100%. It is much, much less than that. It went down by 93.23, depending on how you round, 93.236%. Okay. So a little weird, but hopefully you're getting used to how these functions are changing over time, that growth factor, how to find it, and things of that nature. Okay. So now I think it's going to be important for us to look at a table. So if you could jump down, we're just going to do number 4. Okay. So for number 4, if we started with number 3, do you see how they tell us what is happening at 0? That is always going to be our initial value. They haven't told us that here. But let me show you how we could figure it out, okay? So what we want to do is we want to compare 2 of these things right here, okay? Well, you know what, let's do it like this. Okay, so you know that formula I gave you earlier, that a times b to the x equals f of x. Sorry, I kind of wrote it backwards. Okay, so let's think about the point 1 to 60. If I make my x 1, so I'm going to put x of 1 right there, I should get an answer of 260. Okay, so let's fill in what we know. So I know that 260, this might not give us everything we want. Yeah, it's not going to. Okay, let's do it like this instead. Oh, sorry. So it's actually, let's use this one can help us. I think that can help us. Yeah, let's do that one. Okay. So do you see how this is 3 years apart? So we can see our growth factor, our 3 unit, it has to be a 3 unit growth factor because it's 3 units away. It's just your ending value divided by our beginning value. So it's just going to be any two things that are 3 units apart. So I could have used the 4 and the 1, or the 7 and the 4, any of these. It will all give us that. Okay, so if I do 278.2 divided by 260, because they are 3 units apart, I get my 3 unit growth factor. Okay, so my 6th unit growth factor is just our 3 unit growth factor squared. It's just, you double the power, not the number, you double the power. So not the percent change, but the new growth factor, we're just going to square it. And we get 1.1449. But if they want percent change, we have to take off 100%. So that is 114.49% minus 100% is 14.49%, is the percentage I went up, 0.14, 14%. Okay. Now our 1 unit growth factor, we have to take a third of the 1.07. So we're going to take 1.07 and we're going to cut it into 3 pieces, because that's the 1. How do we get, or that's the 3. 3 divided by 1 is 1/3. So if we take 1.07 to the 1/3 power, I don't know how many places they rounded. They did 1.023, so we'll just keep it like that. Okay. Now, if we want a 1/4 growth factor, we had a 1. Let's just go 1 step above that and take it to the 1/4. It's easier to relate that 1 unit growth, because, okay, so let's think, if this is correct, if I take that to the 6th power, I should get that. If I take that to the 3rd power, I can get that. So you can check it very quickly. If you take the 1 unit growth to the 6th power, you better get that. 1 unit growth to the 3rd power, I better get that. 1 unit growth to the 4th power, should get a 1/4 of a unit. So 1.023 to the 4th power is 1.00565. I got 5.7 because of the way I rounded, so let's make it 5.7. Okay. Now, what is our initial value? Okay, so we have to go backwards, right? Let's think about, if you know the first value, we need to divide off the factor, go 1 step back. So this is our 1 unit growth factor. We're just going to take our first value, that was at 260. Good morning. And we're going to divide 260 by the growth factor that is for 1 unit. 260 divided by 1.07. We'll go backwards 1 step, and I get let's make 260 divided by 1.07 is 242. And let's round it to 243. It's so close. Okay. So now we have a formula. Now what do we use? Okay. Now remember our formula. Let me write it right here. Is f of x equals a times b to the x. Okay. So our formula should include the a value we found in part E, the 1 unit growth factor that we found in part C. Those are the easiest ones to use to plop right into our formula. So our formula is our initial value times our 1.023 to, our 1 unit growth factor. Oh, wait. I think some of you were looking at me like I'm a little crazy. You have to divide, see how this is 1 unit away? So if I want to go 1 unit back, I have to divide by the 1 unit growth factor. See how I didn't do that there? I have to divide by 1.023. I'm so sorry. Okay, so 260 divided by 1.023 is 254.2. 254.2. Okay. So now we have our A value. You go one step back, you divide by the 1 unit growth factor. Go 2 steps back, you divide by the 2 unit growth factor. So, okay, so I'm almost right here. Okay, so that is 254.2 times 1.023 to a power of x. Okay, now how could we check that we are right or wrong or whatever? If I take that formula and I plug in 1, so 1 is my power, you should get 260. If I take that formula and put in a power of 4, I should get 278.2. Power 7 gets you that, power 10 gets you that. So our formula should work for the table listed, or we didn't do it right, okay? So this is your initial value at the 0 mark. This is your 1 unit growth factor. Okay, so hopefully that helps you there a little bit. Now let's jump to our graph. Let's jump to number 5, which is an example of an exponential growth. Okay. Now, the reason we know it's a growth is because it's growing from left to right. It is an ever-increasing function. So this should be a growth just by looking. Now, how can we check? Okay. So let's do something here, and this might help clarify what we were actually doing on the table earlier. Do you see how from the 2 points that we have given, our change in x is 2? We've gone 2 up to get from there to there, okay? So we know, hopefully, that 40 so I'm looking at the y values, 40 divided by 15.625 is whatever we want squared. So it is our 2 unit growth factor naturally, but it will help us find our 1 unit growth factor. They have an asset, but we have to know it for the formula anyway. Okay, so let's just do 40 divided by 15.625, and we can do that because they're 2 units apart. We get 2.56, okay? So half of that will be our 1 unit growth factor, which we need for our formula. That's our B. So just take 2.56 to the 1/2 power. We need to cut that in half. So if we square root 2.56, we get 1.6. So now we know our 1.6 goes into the formula, okay? So, and that was actually right here too. No, that would be our 1 unit. No, we're okay. Okay. So now, so that's our 1 unit growth, which is great. Let's jump to this one right here, C, our 1 unit percent change. If we write that 1.6 as a percent, that's 160%. So we've gone up by 60%. So 160 minus 100 is a 60% change. So that's why I did this first. So then it leads us to that anyway. Okay. Okay. Now we know that the 1 unit growth is 1.6. You can take that to the 6th power, or you can take this answer to the 3rd power. Let's do both ways to show you that it works. So 2.56 to the 3rd should be the same as 1.6 to the 6th. Our 1 unit growth times a 6th power, our 2 unit growth times a 3rd power. And we get, for both of those, an answer of 16.777. Okay. Now, a 1/2 unit growth, I would always compare back to a 1 unit. So our 1 unit to the 1/2 power. So if you know the 1 unit, you can find any of these very quickly. So 1.6 to the 1/2, I think is 0.4, but let's make sure. It sure is not. Okay, wait, 1.6. It's rounded to 1.265. I think is a good thing to do it. Okay. And now we need to find our initial value. So do you see how let's go with this value. It doesn't matter. Do you see how that's 1 unit away from the 0 mark? See, it's 1 to the right of 0. Okay. So if we need to go backwards to find, we're looking for this point right here. That's our initial value. And so to do that, take your 40 and divide off the 1 unit growth rate. So divide by 1.6. Because I need to go 1 unit back, I divide by 1.6. If I needed to do 2 units back, I would divide by 1.6 squared. If I needed to go forward, I would I would multiply by those things. Anyway, 40 divided by 1.6 is a 25 initial value. That's our A. So now we know our A, we know our B. So now we are ready to set up our functions formula. Okay, so what is our functions formula? So remember, it's always f of x equals a times b to the x. So in this case, it's f of x equals 25, 1.6 to the x power. So that's our formula. Okay. Now, the next question they're going to ask us is, what is the average rate of change of r of x with respect from the x values from -1 to 1? Okay, let's talk about our average rate of change. Our average rate of change is just the slope between those 2 points. So we're going to take, it's always ending minus beginning. We're starting at -1. We're ending at +1. So what is the function value at 1 minus what is the function value doing at -1? Well, we've got the points. They've done them already for us. At 1, we're at 40. We started at 15.625. And then this just becomes 1 plus 1. So we can do average rate of change between an interval. We've done this formula hopefully before, if you remember. So this is 24.375 divided by 2, which is 12.1875 units that the function is changing for every 1 unit. So the function height is changing by 12 for every 1 unit over to the x value. Okay. So let's not worry about that part. Okay. So hopefully that has helped you find the equation. I do want to do the decay one underneath it, and maybe one of the word problems, because I know that I saw a caffeine problem the other day. Okay, so let's do this as quickly as we can. So first, check the points you have. How far apart are they? So they are 1, 2, 3 units apart. So the growth factor is going to be, how did the x value change? So I'm sorry, the y value change. So it ends at 36.84. What part of the original 60 is it? So we're just going to divide. So 36.84 divided by 60. And so it is 0.614. So if we wanted the growth factor, that's our growth factor to the third. We don't want our growth factor to the third. We want our growth factor, so we can take the cube root of it, or you can actually put a 1/3 power. So 0.614 to the third power is 0.23148 is our 1 unit growth factor. So how do we find out how much it is actually changed? Okay, how much has the function actually changed? Just to say, that's incorrect. I'm like, that's not the right number. Okay, let's do it one more time. So if any of you are checking in your calculator, I just entered it in the calculator wrong. So it's 0.614 to the 1/3 power, or you can use the cube root. Okay, that's better. Okay, I'm like, wait, that's a horribly small number. Okay, 0.845, I think is actually 0.85 is better. Okay, so let's think about our 1 unit change. 0.85 is the same as 85%. So we need to always subtract 100 from whatever we started at. So that is a decay. We went down by 15% every time. So you can highlight these are all decays. Okay. So this is our B that we're looking for. So let's do a 6 unit growth factor. We have a 3 unit. To get to a 6, you multiply by 2. So take this to a power that multiplies it by 2. So because this is an exponential function, 0.614 squared is about roughly 0.377, I think is a okay representation here. Trying to get this to move back where it was. There we go. Okay. Half a unit, just take our 1 unit, or 0.85 to the 1/2 power. So our 0.85 to the 1/2 power is approximately 0.922. What is our initial value? Okay. What's great about this particular one is they have shown us our initial value on the graph. Remember, our initial value is what is happening at 0. It's our y-intercept, or sometimes they refer to it as our vertical intercept. So it's just 60, which is awesome because we didn't have to do any calculations. If we wanted to do the calculation, we could take this value, and if we divide it by 0.85 to the 3rd power, it should get us to 60, however you want to do. Okay. So now we can do the function formula pretty nice. Remember, that's just a times b to the x. Our a value is 60. Our b value is 0.85. So that would be 0.85 to the x. So there you go. Okay. I'm not going to worry about g. Could you please jump now? I want to do just a few before we jump into the pre-class 4-5. I would like to talk about number 7. Let's do 7, and I think that will give us a picture of what's going on. Maybe we'll jump to the caffeine one too. Okay. Anyway, let's look at 7. It says from the start of 2006 to the start of 2011, the number of people in the U.S. Living in poverty increased exponentially from 36.46 million to 46.34 million. Okay. Now you'll notice that that is a 5-year span. So we can use those numbers to find our 5-year growth factor pretty quickly. Okay. So we're just going to take where was it ended. Sorry, I'm still writing with my highlighter here. Where did it end? 46.34 million. And where did it begin? And the millions then would cancel each other out. If you divide 46.34 divided by 36.46, you would get that it is approximately 1.271. Now that is our 5-year growth. We do not know the 1-year growth until we take the 5th root. So 1.271 to the 1/5 power, because we have to make that a 1. How do you make 5 a 1? You multiply by 1/5. So 1.271 to the 1/5 power is approximately 1.0491. That's good. Okay. So what percent change? Well, that is 104.91% minus 100%. It went up by 4.91%. It is a growth. And we should have seen the fact that our population went from here to here. Our population in poverty went from here to here. It went up. Okay. What is the initial value? We're going to assume that they aren't going back to time 0. We're going to start with 2006. So we're just going to use that 36.46 million. And now we're ready to make our function. Use your 36.46. And we'll just make it be in millions, okay? So that we don't have to do that many times. We say, oh, our answer is going to give us millions of people. And then we would use that 1.0491 that we found in part B so that we could find that percent change. And our power would be x. So hopefully that kind of leads from what we were doing before. And now, do we have any questions about how that one came about before I jump to the caffeine one? Okay, jump down please now to number 9, the caffeine problem. Jump to number 9, the caffeine problem. It says the amount of caffeine in your body decreases by 27% for every 4 hours. So a 24-hour decay factor, because it's going down by 27%. Let's think about the fact, if it's going down by 27%, 100 minus 27 is 73% remaining. So that growth factor for 1 hour is 0.75. So a 24-hour decay, or that decay factor, a 24-hour decay, 4 goes into 24 how many times? 6. So we're just going to take that 4-hour value and take it to the 6th power. So 0.73 to the 6th power is 0.151, I guess, is good for now as far as rounding. And please watch how iMath asks you to round, because as much as you can actually enter the full equations, probably the better. So what is the percent change? See how these two go together. So we had we ended with 15.1% minus 100%. You'll notice hopefully that subtracting 100 every time, and we went down to negative 84.9%. It dropped by 84.9%. Okay. What is the 1 hour decay? So we know that 0.73 is our base to the 4th power. So to get rid of that 4, we have to cut that power by 1/4. So just take 0.73 to the 1/4 power, and our hourly decay factor is 0.924. So what is our 1 hour change? What do we keep doing every time? Subtracting that from 100 as long as it's in percentage form. So that would be 92.4% minus 100%, which is Should be a negative because it's a decay. It's negative 7.6%. So that's done. Turn it in, open up iMath, click on the calendar. We're going to do pre-class M45. Okay, so turn that in. Please turn that in. We're going to do pre-class M45 together. Okay, turn that in, open up pre-class M45. Let's do that together. Now, at the top of the page is some information about growth rates and that interval of change of your x, okay? And then we have some practice problems. Please jump to your practice problem. Now remember, my numbers and your numbers might not be coinciding here, so please make sure that you change if you need to. If you need to grab a calculator at this time, that would be a good thing to do. It says here, as x increases throughout the function's domain, what does the function do? Does it decrease? Does it increase? Does it sometimes decrease, sometimes increase? Exponential functions always either increase or decrease, okay? This is what determines that. If it's bigger than 1, anything at all bigger than 1, it is always a growth. So it is always going to be increasing. If it's a decay, a number smaller than 1, it's always going to be decreasing. You need to charge. Okay. What is the 1 unit growth? Just make sure this is an x power, which it is. Just a plain old x. So our growth is that b, that 1.46. For me, it might be something different for you. Half a growth. You guys don't do the math in your calculator. Just put 1.46 to a half power. I think that's the easiest way to do it, and let iMath take care of the actual math. And then do 1.46 for this one to a second power. Now that one we're going to need to at least preview. So if you have that preview off option, please preview it. My preview says 2.1316. As a percentage, that's 213.16. If I take off 100, that's how I'm going to get E. So in this case, it went up by 113.16%. Okay, so make sure you're getting that to work out. Please work that one out for me. Everybody getting theirs to turn green. Anybody have questions? Raise your hand. I'll come back and look. So use the preview in D to answer part E, but you have to take off 100% in order for it to work. Percent change is always, how did it change from 100? Everybody ready to move on to the next question? Okay, now let's look at this question. Okay, so consider the exponential function. You'll notice that the number we have here is less than 1. So this is a decay, which is always decreasing. It's always going downhill from left to right. The 1 unit growth factor is that 0.75. So if I want it to the 1/4 growth factor, just choose 0.75 to the 1/4. So here, if I want this, that's 0.75 to the 6th. Oh, change your numbers accordingly to fit your circumstance. I need to use the preview for D to help me answer the question of E. My preview for this says 0.177978516. Now I'm going to use the preview because I don't want iMath to yell at me. That is 17.7978516%. So I have to take off 100% from that. If I take 100 for that, I get negative 82.202148444. I'm going to go out quite a few. However many decimal places the preview shows, I would use that, okay? So just move that decimal place to the right 2 places and subtract 100 from that value. And that is going to be your percent change. So that should be done. Hopefully everything is turned green for you. I'll give you a minute to do that. And then go back to your calendar, look on October 13th, open up homework 4.5. I'm going to show you that right now. We're going to do that together. So please, at this time, once you have finished that, could you please open up homework homework 4.5. Let's do that together. Okay, so 4A, my 1 unit growth factor for my equation, again, we might have different numbers, is that 1.62 I see in the parentheses. So a half unit growth factor, guess what I'm going to type? I'm going to let iMath do the math. I'm going to type in 1.62, use my caret button to tell what I want to power, and then in parentheses, I'm going to use 1/2. What is a 2 unit growth factor? I'm going to do 1.62 to a power of 2. I'm going to let iMath do it. But you see how for part A2, I see the preview. So that is 262.44%. 262% minus 100 is 162%. But I'm going to make it, I'm going to do 162.44, and I'm going to just type in some zeros. Let's see what iMath thinks. Yeah, okay, so mine worked, okay? So once this unit, this is right here, is my growth factor, 1.62. Because it has an X there, be careful. So I just can take it to the half, take it to the second, and then whatever my preview says, I can use that to, see my preview was 2.62, which is 262%. Just take off 100% from that, okay. So that should be your first one. Hopefully you're doing that with me. Now let's take a look at part B. It says, consider the exponential growth. Here's the problem. See that fifth, that 5, okay? So this is a 5th power. So a 1/5 growth rate should be what's in there, 0.711, I believe. Let me just verify that, because I don't want to steer you wrong. Okay, because of the fact that 5 was there, that is representing 1/5 of what the original would have been. So a 1 unit growth rate, we just got to take that answer, which is a 1/5. What would we multiply 1/5 by to turn it into 1? 5, right? So we're just going to take that to the 5th. Now your number, my number might not be the same. Adjust accordingly. And then what is the 1 unit growth factor for G? What is the percent change for the 1 unit percent change? Now that is 0.18. That's 18% from 100. 100 from that should give us a negative answer, because if we take 18, and I'm going to put a lot of those decimals in, 18.16971,033 minus off 100 gives me, for me, negative, make sure you put the negative in, 81.83028967. So that's a little bit about your homework. So if you need help, let me know. Please, for the next few minutes, work on some of this. We have a lot of homework due on Sunday. Okay? So I'll come around and help if anybody is stuck.